Hi math students, it's Mr. Hajgasum, and today we're going to learn how to use Venn diagrams to calculate conditional probability. Now, just to do a recap on probability and Venn diagrams, so here it says a card is selected at random from a pack of 52 playing cards. Let A be the event that the card is an ace and D the event that the card is a diamond. Find the probability of an ace and a diamond. Now, we can rewrite this as using Venn diagram notation, the probability of A and D. So that's the intersection of A and D. So the region where we have an ace and a diamond, well, that will be this region here. And well, how do we go about doing this? So we have 52 playing cards. In a pack of playing cards, 4 cards are aces, and there is a diamond suit as well, and 13 cards are diamonds. So we've got 4 aces and 13 diamonds. And what we also have is an ace of diamonds. So we have 1 ace of diamonds. Therefore, we have 3 aces in this region here. And then for the remainder of the diamonds, we're going to have 12 in here. So this is what a Venn diagram will look like. And the rest of the cards, well, we've got 16 here. So 16, take away 52, that leaves us with 36 cards on the outside. So find the probability of A and D. So that's going to be 1 card out of the 52 cards that we have. So that's 1 out of 52. And if we add all of these numbers up together, we will get 52. So 36 plus 12, that's 48, plus 1, 49, plus 3, 52. Now it says find the probability of an ace or a diamond. So this is essentially the union of A and D. So we can rewrite this using Venn diagram notation as PAUD, the probability of an ace or a diamond. So that's everything in both the ace and diamond set. So I would shade in both of my circles, and that's going to be 16 out of 52. And we don't need to simplify this because the question doesn't ask us to do so. And lastly, it says find the probability of the complement of A. So everything that's not A, so everything that's not an ace, well, we have 4 aces in total. So therefore we have 48 cards that are not aces. So that's 48 out of 52. So this is how we can use a Venn diagram to calculate normal probabilities. All right, and let's move on. However, we also have conditional probability. So conditional probability is a measure of the probability of an event given that another event has already occurred. And we would write this as PBA. So what this means is the probability of B given that A has occurred. And so this is the notation. So the probability of B given A has occurred. Now let's do an example then. So it says here, given that you drew a red card, what's the probability that it's a 4? So we can rewrite this using Venn diagram notation. The probability of a 4, given that a red has already been drawn. Well, let's think about this. What this does, given that we've drawn a red card, so the total number of red cards that are available to us are 26. Therefore, our sample space has been restricted to 26 now because there are only 26 red cards. Now, of these 26, how many of them are 4s? Well, we have 1 4, 4 of hearts, and we have 4 of diamonds. So 2 out of 26 are going to be 4s, given that we've already drawn a red card, and that simplifies to 1 over 13. And again, we don't need to simplify it because the question doesn't state so. All right, and we can also apply this using a Venn diagram. So let's say we have one set is red cards and the other set is 4s. So I would just do 4 here. Now, in total, we have 26 red cards. And in total, we have 4 4s. Now, how many red 4s do we have? We have 1, 2 red 4s, and then we have 2 other 4s remaining. So 1, 2, 4 here. So this is where I would put my 2. And then in my red set, well, I know I have 26 red cards, 2 of which are here. Therefore, this bit will be 24. And then it says, given that we've drawn a red card, well, given that we've drawn a red card, that means this is the circle, or this is the set that we need to look at. Our sample space has been restricted to only red cards now. So again, our total is going to be out of 26. So again, the probability of 4, given that the card is red, is going to be out of 26. And of these 26, how many of the cards are 4s? Well, 2 of them are 4s. So that's going to be 2 out of 26. So this problem, whilst we could solve it without drawing a Venn diagram, sometimes it can actually be easier to use a Venn diagram. And sometimes they might give you a Venn diagram and you have to find the answer from the Venn diagram that's given to you. So it's really important you know how to use Venn diagrams when given a conditional probability question. So very important thing to understand here, and that is when we are dealing with conditional probability, if an event has already occurred, so in this case, the event that had already occurred was that we drew a red card, the sample space for the other event is restricted. So the other event being drawing a 4, but given that this event had occurred, so the event of us drawing a red card had already occurred, our sample space was restricted to 26 cards as opposed to 52. All right, let's do another example here. So now we have a sample space diagram, and it says the table shows the results of a class survey. Find the probability that an individual owns a pet given that they are a female. So if they are a female, that already reduces our sample space. These are all the females that we have. So in total, we have 14 females. And of those 14 females, 8 said yes to having a pet. So the probability of someone owning a pet, given that they're a female, is going to be 8 out of 14. All right, let's do some more examples then. So here it says, find the probability of B given A. Well, given A will restrict our sample space to set A. Now in set A, there are 3 numbers, 2 of which are also in set B, so in the intersection. Therefore, the probability of B given A is going to be 2 out of a total of 3 numbers. 2 out of a total of 3 numbers. All right, let's have a go at this one. So a worded problem. It says, the Venn diagram shows the number of year 10 pupils going on a history and a geography school trip. Find the probability that a randomly selected year 10 pupil is not going on the history trip. So this is not a conditional probability question because our sample space hasn't been reduced. So we just want a student out of, how many do we have? So we have 100 students here. So out of the 100 students, how many of them are not going on the history trip? Well, that's going to be 45 plus 15, which is going to be 60. So 60 out of 100 are not going on the history trip. Now it says not going on the history trip, but going on the geography trip. So not going on the history trip, but going on the geography trip. So this circle here, or this set, I should say, is all the students who are going on a geography trip, but we want the ones who are not going on the history trip. So that's going to be 45. So this is 45 out of 100 still, because the sample space hasn't been reduced. However, with question C, it says, going on the geography trip, given that they are not going on the history trip. So given that they are not going on the history trip, well, that reduces our sample space now. So given that they are not going on a history trip, so who's not going on a history trip? Well, these 15 students here on the outside, they're not going on a history trip. And also the 45 over here are also not going on a history trip. So we have a total of 60 students who are not going on the history trip. Of these 60, how many of them are going on the geography trip? So going on the geography trip, well, that's going to be 45 out of 60. So we get 45 out of 60 students. So the fact that it's a conditional probability question, it says, given that they are not going on the history trip, we need to work out how many students are not going on the history trip. So that's going to be 45 and 15. So that gives us our new total of 60. And out of these 60 students, 45 of them are going on the geography trip. All right, let's do some more examples here. So it says, given that a person is selected has visited France, find the probability they have not visited Spain. So we want everyone who's visited France. That is our restricted sample space. So that's everyone in the France circle. Therefore, our total again is going to be out of 20. And of these 20, how many of them have not visited Spain? Well, these 10 have not visited Spain, so that's going to be 10 out of 20. All right, and let's do a few more questions. So here is another example. It says, a person selected at random, given that they like bananas, what is the probability they do not like apples? So given that they like bananas, so again, our sample space has been reduced to this set here, and that's a total of 25 pupils. So of the 25, given that they like bananas, what is the probability they do not like apples? Well, these 13 here, they only like bananas, they don't like apples, so that's going to be 13 out of 25. 13 out of the 25 who like bananas don't like apples. All right, and the last question, it says the Venn diagram shows students studying biology and chemistry. What is the probability of a student studying biology if they are also studying chemistry? So here we need to sort of break down the wording here. So it says, what is the probability of students studying biology if they are also studying chemistry? So if they are studying chemistry, that means given that they are studying chemistry, so given they study chemistry, what is the probability that they also study biology? So again, we need to reduce our sample space to everyone who studies chemistry. That's going to be 27 students. And out of these 27 students, how many of them study biology? Well, 13 of the 27 also study biology as well. It's going to be 13 out of 27. So very, very important. When it comes to conditional probability, you need to be able to recognize that your sample space has been restricted. So in the case here, the sample space was restricted to only those students studying chemistry. And in the first example, the sample space was restricted to students only studying not studying biology, but only eating or liking bananas. So that's it for today's lesson. I hope you find this useful and all the best. Bye.